Let's go through LeetCode 476. Number complement. For this question, it give us a integer num, and let's find the complement. So what does the definition of complement of number is we flip all of the binary of this number. So for example, 5, that is 101. And when flip, it will become 0, 1, 0, right? So 5, the binary representation, the complement is 2. So for this question, actually, we can, for every number, we write it binary format, right? For example, binary format. Then we flip those kind of numbers, right? So the flip operation is that we have if we want to flip from the right to left, the jth bit. So what we do is that we have one shift left shift J, right? And have this number, for example, a XOR equal to this, then that is a flip. The things that we need to terminate, right? Because to the largest the jth bit from the which is 1 from the right left to right, right? From right to left. So for example, if this is 0, all of this is 0, right? We don't want to flip this. So we need to find the first one. So first one, what is the jth position from the right? Then only flip this part. So there are 2 parts, right? So one is that we find the position, right? The which first bits 1 appears or in the highest digits, the 1 appears, right? And then we flip this part. So let's go through those kind of bit operation, review it quickly. So we know for bit have 1 and 1 equals 1, right? And 1 and 0 equals 0, and 0 and 0 equals 0, right? So for O is 1 or 1, right? Equals 1, and 1 or 0 equals 1, and 0 or 0 equals 0, and 1 XOR 1 equals 0, right? And 1 XOR 0 equals 1, and 0 XOR 0 equals 0, right? So this is the basic operations, and also something like a check the jth bit from left, right? Of a whether it is 1 or not, right? 1. So for this kind of things, we can do a kind of say use AND operation, right? And see if this one done equal to 0, right? So this is it. And also for this question, right, we know flip the jth bit of A, right? So we do a XOR equal to one shift left shift J position, right? And also we know and is actually to find its interactions, right? Interactions is for example A and B, right? And the union is A or B, right? And for example, if we want to see if C is a subset of A, right? So what we do is that we have A trying to see whether A and C equals C, right? And if C is a subset of A, right? We remove the state C from A, right? If C is a subset of A, remove state C. So we also use XOR, right? So use A XOR C, right? Of course, we can use A minus C, but this is not efficient to XOR. So we use XOR. And there are also some other operations to review. For example, the largest subset of A, right? So that is we remove the last one bit A bit one bit one from A state. So we'll use A and A minus one, right? So what does this one mean is that, for example, A is 1, 0, 1, 0, 1, right? So we remove the last one. So that is 1, 0, 1, 0, 0. And so if, for example, the question, let's count how many ones in A, right? So what we do is that we write something like a while A down equal to 0, and we have A and equal to A minus 1, and then for this one we have count plus, right? And the last thing is that to enumerate all of the state, enumerate all of the substate of A, right? So for example, A has something like 1, 0, 1, 0, 1, 1, 0, right? So its substate can be something like a 1, 0, 1, 0, 1, 0, 0, right? We remove the last one, right? And then we keep removing, right? And so its subset state can be, for example, 1, 0, 1, 0, 1, 0, 1, 0, right? Or it have a lot of subsets. So how can we, the efficient way to enumerate those subsets is we write something like for I equals A, right? I doesn't equal to 0. And I equals I minus 1 and A, right? So this I is it's a subset, right? So we write this kind of statement. So this is the way to enumerate all of the substate of A. Okay, so after review, this question is actually not gonna need all of these binary operations, right? So we just need to use this flip jth bit of A, right? And also possibly we check the jth bits of A to find the position of first one, last one, let's say from the right to left. So let's begin to write code for this, right? So we need to find the position. So we have position s equals -1. This is its position for int I equals 31, right? I greater equal to 0, I minus. So let's say if num and right and one shift I, right? And this one down equals to 0, then let's say s equals r, right? So we find the the ice digits, the first ones digits from the position from the right to left. So we need to break, right? So this is check for the ice bit whether it is 1 or not. And for this question, then you will find it, right? We need to flip it for int I equals to 0, s smaller equal to s, right? Because we need to flip from right to left to s, right? And plus plus. So for the flip is num XOR equal to 1 left shift R, right? So in this case, return num. If num, and so for this one we should have one more parenthesis. Write this one as Python code. So let's say s equals -1, right? This is the highest bit set. So let's say for I in range, we use 31 to -1, right? Because we need to iterate to 0, and we use -1 to every time decrease by 1, right? And if one, if let's say num and 1 left shift R, right? Down equal to 0, right? So for Python, we can just write this. Let's say s equals to I, then break. Then we need to do the flip. That is for I in range. So we need to have because the higher set s, we also need to flip. So we have s plus 1, and num x or equal to 1 left shift R, right? And then in the end, we just return now.